History isn't just about kings and battles, it's a blueprint for survival written in stone. Sometimes the greatest lessons come from the materials our ancestors used. Imagine a substance so revolutionary it shaped an empire and outlasted its creators. Roman concrete. The Romans built for eternity, facing challenges that demanded innovation. They needed a material both strong and adaptable, and found it in the volcanic landscapes around them. By harnessing volcanic ash and quicklime, they created concrete that could withstand the elements and even grow stronger over time. Today, our world is built on concrete, yet our structures are fragile and short-lived. What if the answer isn't to invent something new, but to look back? Roman monuments offer clues to a different way of building, one that embraces nature, not fights it. We'll explore how their concrete could heal its own cracks, a feature that sounds like science fiction. This isn't just a story for engineers, it's a lesson for all of us. True endurance comes from adaptability, and the past may hold the keys to a sustainable future. Let's journey back 2,000 years to rediscover what the Romans knew. Stand beneath the Pantheon's dome in Rome, and you feel the weight of history. For nearly 2,000 years, rain and sunlight have poured through its oculus. The Pantheon has survived empires, earthquakes, and centuries of change. Its unreinforced concrete dome, still the world's largest, defies gravity and logic. The secret? A carefully graded mix of Roman concrete, heavier at the base, lighter near the top. The Romans adjusted their recipe as they built higher, showing a deep intuitive grasp of materials science. They weren't just builders, they were engineers, geologists, and physicists. The Pantheon is their masterpiece, a challenge to every architect since. By modern standards, it shouldn't exist, yet it endures, designed to last. The Pantheon isn't just a temple, it's a message from the past. It tells us we've lost vital knowledge about building for permanence. This enduring puzzle dares us to solve it. The Romans built not for the moment, but for eternity. What can we learn from their legacy? What made Roman concrete so special? The answer? Opus caementitium. Unlike modern concrete, the Romans used volcanic ash, pozzolana, mixed with quicklime and rock. This hot mixing process created unique chemical reactions, forming a stable, non-corrosive binder. The result was a man-made stone mimicking nature's most durable formations. Roman concrete could be poured underwater, enabling harbours and bridges that shaped the empire. It was perfect for ambitious projects, from aqueducts to the Pantheon's dome. Opus caementitium wasn't just a material, it was a tool of empire, imposing order and permanence. The Romans harnessed the earth's power to build structures that would last millennia. Their recipe changed the world. For centuries, the durability of Roman concrete was a mystery. The breakthrough came when scientists found tiny white chunks, lime clasts, inside the concrete. Once thought to be flaws, these clasts were actually the secret to self-healing. When cracks formed, water reacted with the lime, triggering a chemical process that sealed the fissures. Roman concrete could literally heal itself over and over for centuries. Unlike modern concrete, which is static and vulnerable, Roman concrete was dynamic, built to repair its own wounds. This was no accident, but the result of deliberate hot mixing. The Romans engineered a living stone, collaborating with time instead of fighting it. What we once saw as sloppy workmanship was actually advanced material science. They pioneered smart materials long before the term existed. Their concrete didn't just resist decay, it adapted and endured. The secret was hidden in plain sight. Compare Roman concrete to modern concrete, and the differences are striking. Modern concrete is strong but brittle, relying on steel rebar that eventually corrodes. Cracks let in water, leading to rust, spalling, and costly repairs. Our infrastructure often lasts just decades before major maintenance is needed. Roman concrete, with no steel to corrode, was built for resilience and longevity. Its chemical structure and self-healing ability made it stronger over time, especially in harsh environments like seawater. The Romans' method was also more sustainable, using lower temperatures and volcanic ash. Today, Portland's cement production is a major source of carbon emissions. The Romans teach us that true strength lies in adaptability and endurance, not just brute force. Have we sacrificed long-term durability for short-term gains? Their approach challenges us to rethink our priorities. The strongest material is the one that can adapt and survive. The lesson: build for centuries, not just for now. The aqueducts were Rome's backbone, carrying water across vast distances. Built with revolutionary concrete, they enabled cities to thrive and populations to grow. These structures had to be strong, waterproof, and resilient, qualities delivered by opus caementicium. Monumental bridges, like the Pont du Gard, are both functional and beautiful, surviving for millennia. The Romans lined channels with waterproof mortar, but the core strength came from their concrete. Unlike modern bridges that need frequent repairs, Roman aqueducts have endured with minimal maintenance. They're a testament to the value of resilient materials and long-term thinking. Infrastructure, the Romans knew, should not be disposable. Their concrete made lasting public good possible. The aqueducts remind us: build for permanence, not obsolescence. Rediscovering Roman concrete secrets comes at a crucial time. We need sustainable, resilient infrastructure for a growing world. The Roman approach shows that adaptability and self-repair trump brute strength. Modern scientists are now working to reverse engineer these ancient techniques. The goal isn't to copy the Romans, but to apply their principles to new materials. Imagine concrete that heals itself, or seawalls that grow stronger in salt water. Learning from the past could save trillions in repairs and reduce our environmental impact. The Romans built for the next millennium, not the next quarter. Their wisdom challenges our obsession with the new. Sometimes the best way forward is to look back. The story of Roman concrete is a circle, ancient monuments inspiring modern innovation. The Pantheon and aqueducts are not just relics, they're classrooms in durability and resilience. The Romans embraced complexity, using flaws like lime clasts to create self-healing stone. Our pursuit of purity has made modern concrete predictable but fragile. The path forward is clear. Combine ancient wisdom with modern science. We can build cities and infrastructure that endure for centuries, not just decades. The Romans left us a blueprint for resilience, written in stone. Their empire is gone, but their concrete endures. A quiet reminder that the best technology isn't always the newest. Sometimes the future is built by rediscovering the past. The next engineering revolution may rise from ancient dust and forgotten wisdom.